then how can you connect to what we did yesterday? And that's connected to today's work. Okay, anyway, um, can we see the screen there?
Yes, sir.
So we have done A of each numbers yesterday. Uh, we have been doing this for the last week. Area of parallelogram and triangle theorems, our theorems. So we did A of these numbers yesterday, and we were supposed to do this B of each numbers. We have done few questions of B yesterday as well, and we have left number B of each numbers to be done today. So it's today's student's turn to do the work. So what can we do now? The one who didn't come yesterday, how can we do them? Yes, how can we do it? As I said, we have been doing this one. We did this exercise yesterday, A of each numbers, and we did few B also yesterday. And what I was planning is I was planning to give this one as classwork to my students today, the remaining one. So the one who came yesterday, Ayus and I don't remember the other people there. Should we start? Should we try number B today? A we have done already, so only B are left today. Like we did this one, we have done this one already yesterday, and A of each numbers are done yesterday. So can we try doing this one today? Oh, hello people out there.
Yes, sir, we can try.
Okay, so you tick garachani. This one let's try today. So my planning was to give this one to my students today to identify or to understand how much they have understood to solve the our theorems. So it's test for me as well. So how much my students have understood. Let's try this one first. Ayush, will you try? Everyone?
Yes, sir, sure.
Okay. So
So did you
do you
solve
remember?
that question?
Do we remember? Do you remember we have done A yesterday of all the numbers
Yes, sir.
up to
I know.
um up to this up to these questions, whichever you see on the screen. We have
Yes, sir.
done A. So A and B are similar. Simply the thing is in B we have converse type of relationships. So that's what we have to prove in number B. So let's try this first. Let me see how much our students have understood doing this one. Okay, in this question, if you read the question over here, ABCD is a parallelogram. ABCD is a parallelogram, and BF equals to EF. BF equals to EF. This is going to be the classwork. Okay. What construction do you think is required here? What construction will help us doing this theorem easily? The one who came yesterday, I think they can give me idea here. What condition, what construction will help us solve or prove this theorem easily? I'm sure Ayush can give some idea. What construction do you think is required?
So wait a minute. I'm trying.
Yesterday also we did the similar one.
Join
Remember?
FC.
So
Join, join
FC.
FC. Okay, fine.
Yes,
Okay,
sir.
let's join FC. Let's join F and C. F and C. And now, if we join F and C, what are we going to get? Okay, let's make the plan over here first, man. Let's make a plan over here. Obviously, uh, we need to connect area of ABCD to area of EFG. EFG is here. EFG is this triangle. And what we know is when in a triangle, if we have a median, median bisects the triangle, right? So that condition appears here automatically when we join FC, and at the same time, BFC is a triangle on the base BC, and ABCD is a parallelogram also standing on the same base BC. So, what is the relation between the triangle and the parallelogram if they stand on the same base and lie between the same parallel lines? Can anyone help me?
so
What is the relation?
complicated.
What is the relation between the triangle and the parallelogram if they stand on the same base and lie between the same parallels?
The area of
Sure.
triangle of that of
Want me to?
parallelogram.
Okay, so can we write here? Can we write here then? Since we have to show the relation with ABCD, can we write like this? Can we write parallelogram ABCD? This is just my plan, and we will work out on this plan later on by writing it systematically. So first of all, you need to have the idea, or you have to jot down the idea by which we can prove the theorem. So ABCD parallelogram line E, ABCD parallelogram line. Can we write it as 2 times of triangle BCF? Can we write? It's 2 times of BCF.
Yes, sir.
Okay,
Yes.
BCF. And which triangle is equal to BF or BCF? Which triangle?
EFC.
EFC, right? Okay, all
Yes,
right.
sir.
EF, EFC. And but we
So
have
and
we have to
again,
yes,
so
yes.
FZ is the median.
FJ is median of which triangle?
So triangle EFC.
How? Why? Why?
So why?
Yes. Why FG is median?
So because F is the midpoint of the line E and B, of line EB.
F is the midpoint of the line BE, right? F is the
Yes, sir.
midpoint of
And
line
area is the
BE. And you mean to say that G is also the midpoint of G will be the midpoint of EC? Do you mean that?
yes, sir.
Okay. So what is the reason behind it?
So because
You have to go back to grade 9, sorry, grade 9, where we have learned that there was a theorem called midpoint theorem, right? In triangle
yes, sir.
EBC, in triangle EBC, F is the midpoint of BE, right? Which is given. And can we say FG is parallel to BC? Can we say FG is parallel to BC?
Yes, sir.
Yes. So the midpoint theorem says that when we draw a line joining the midpoint of one side parallel to another side, that will bisect the third side. That's why G will be the midpoint of FC. All right. If G is the midpoint of FC, FG is median of triangle
EFC.
EFC. So that means
Yes, sir.
in place of EFC, we can write two times of triangle, two times of triangle,
EFC.
two triangle of triangle EFG, which we require here. EFG,
Yes, sir.
EFG. So we will get here four times of triangle EFG, and simplifying this one, we will get the relation that triangle, area of triangle EFG is 1/4 of the parallelogram
Parallelogram ABCD.
ABCD. Okay, take 2 minutes time to write it systematically. I think we have done so many theorems here, our theorems. So now I think you are perfect in writing the reasons. Just simply in just roughly you can write, because after the class is over you can figure out how to write it systematically. For now, you just note down the necessary reasons over here. So, for example, in parallelogram ABCD, the area of parallelogram ABCD will be two times of triangle BCF, and you can write the reason that they stand on the same base, BC, and lie between the parallels AD parallel BC, so on, so that you'll not forget later on while doing it. Take 1 minute to do it. Then we'll go to number B of the next number. After doing this one, we will jump into the next B. Next B, which is this one. Okay. Now think for 1 minute how to figure out the solution of this number B. A we have done yesterday. Remember, Ayus?
Yes,
This one, A,
I do.
we have done yesterday. So let's try this one. Take 1 minute to think of the idea, how to solve it,
Okay, sir.
and then we'll figure out. Okay, did you get? Hello, people out there. Did you get any idea? This is very easy because this is also similar to number A, which we did yesterday. Anyone? Any idea came into your mind? Miss Sovana, did you get any idea? Number B.
Kind of, but not.
You were present here, right? Yesterday. So we have done A of all the numbers. So probably that must have given you idea how to solve number B as well. So tell me, what do you think is the necessary construction which will help us to prove this one? This is similar to number A, which we did yesterday, right? This one. This one was done yesterday. Yeah. Yes, Manusta. What do you think is the necessary construction which will help us to prove this theorem?
Um, I think like it should be drawn from B to that midpoint of A and C, I guess.
Uh, did you mean from B? From B or from D?
From
So
B,
from B, where to join? B to
midpoint of A and C.
A and C. So is midpoint of A and C given?
No.
No. And usually what happens is while doing the construction, we don't construct in such a way that saying specific um, specific conditions like joining the midpoint. Even if you join here, okay, let us join here as Sovana said. If you join the midpoint over here, let's say what should I give the name to this midpoint of AC? Q? Okay. Will it help us? Any other people? Do you think that this will help us to prove the theorem?
No, sir.
Why do you think that it's not helpful?
Because there is no use of this.
Bafre. Oh, but we can figure out. Maybe.
So
Okay.
I just think
So
only.
okay, you thought that this will not help us. And
I'm
Sona,
also
how do you think that this will help us? Miss Sovana.
Yes,
We want
sir.
to we want to connect the area of BPQ, right? First of all, you have to see what is given and what to prove. And we have D as the midpoint of AB, and we have to connect. And these two lines are given parallel over here, so there must be use of parallel lines, which is given over there. And we have to prove the area of triangle BPQ, BPQ, BPQ to the area of triangle ABC. So you might have thought that when we join here, when we draw here BQ, Q being the midpoint of AC, we can say that maybe one triangle is half of triangle ABC, and this triangle can be connected to this one, right? But do you think that this triangle BPQ will have any relation with this triangle BPQ? BPQ? Shobana, wala? Do you think?
I don't know.
Okay. I don't know. So we can think, yes, we have to do mistakes and we learn from mistakes, right? So nobody is perfect in this world. Okay. Let's hear from Ayus also. What is your opinion here? What construction
just
do you think will be helpful?
so 1 minute only. So I think D join D to C.
Okay. So you thought that joining DC, drawing DC will be helpful. Why do we think that this will be helpful is because we have DP parallel to CQ. DP is parallel to CQ. That means we have here two triangles, right? DCP and triangle DPQ, having common base DP, their area will be equal, and at the same time PDC PDC will be half of the triangle. Yes, PDC will be half of the triangle ABC as well, right? Because DC will be the median. Okay, think in this way, Miss Sobana. Will you think, please?
Yes,
I think
sir.
this will. I think this will be helpful now. Joining D and C, joining D and C, and DC being median of the triangle ABC. I think this will help you to prove this one. Can you think for a while after joining DC? Let's think for a while. Okay, did you get? Did you get the idea? After having this DC, the constructed part here, now let's try doing this one quickly because we don't have too much time. Okay, then first one, can we write here? Can we write here? Can we write here triangle ABC because we have to show the relation between this triangle ABC. So let's write over here. Let's think in this way that can we write ABC triangle, area of triangle ABC equals to 2 times of area of triangle BCD. BCD. Do you have any problem writing this one?
Yes, sir.
Can we write triangle ABC? Triangle
Yes.
ABC equals to 2 times of triangle BCD.
Yes, sir, we can.
Okay. What next then? 2 times of, as I said earlier, we have DCP and DPQ equal in area. Now, if you use the whole part axiom and try to break down this BCD, can we write triangle BCD, area of triangle BCD as the sum of triangle BPD plus triangle which one? BPD plus triangle PDC. Can we write?
DPC, yes, sir.
PDC. And what we have is we have that triangle PDC equals to which triangle? Triangle QPD, right? QPD. So using this PDC, in place of this PDC, let's write 1, and this will come in number 2. Number 2, this will come in number 3. In number 4, can we write triangle ABC equals to 2 times of area of the triangle BPD plus, in place of PDC, can we write QPD? QPD, QPD, which after joining these two triangles, what are we supposed to get here is BPD, BPD and QPD. What is the sum of these two triangles?
Triangle BPQ.
Triangle BPQ, yes. Triangle BPQ, which we have to prove. So in how many steps? 1, 2, 3,
Four.
4, or let's say 5. In
Yes.
5 steps, we can prove the theorem. Okay, just quickly write down the required reason, valid reasons over here for this theorem, and let's move to another theorem. Okay, done? Are we done? Okay, let's move to the next number. We haven't done this first of number 17. So let's try doing both. Okay. In the given figure, ABCD is a trapezium, and M is the midpoint of BC. And we have to prove that triangle AMD is half of the trapezium ABCD. So here, let me try this one, and you can do the next number, B number, because since yesterday we have been doing A, and B was given classwork to the students. So let me also try this one. In construction, let's produce AM. Let's produce AM, and let's produce CD or DC up to here, which intersect at the point N, and now from that side, can you tell me, can we prove these two triangles congruent? Triangle, can we prove that triangle ABM being congruent to triangle MNC? Can we show these two triangles congruent?
Yes, sir.
No.
Yes, sir, we
What,
can.
which exam, which test is verified?
RHS.
RHS, SSS, SAS, AAS, ASA. RHS, how RHS? Is there right angle?
No, sir, we can do
Iris.
it. SSS, sir.
Wait. So this does not work. RHS does not
S-
work.
SSS axiom, sir.
Which one?
SSS.
Okay, how? BM equals to MC, right? And
Yes, sir. And DC is parallel to AB.
so what then? Are they equal?
And so aren't they?
No, they're not equal. How can they be equal? Not SAS, not SSS.
Okay, sir.
Now you have to figure out in these three, either SAS. SAS also is not possible because we don't have two sides over here. So this doesn't work. AAS or SAS? Which one?
Yes.
Which one? Which test can be verified? Which exam? Which test of congruency will be can be verified? Okay,
So I
anyone?
think ASA. AS.
ASA? Okay. How ASA? These two angles, vertically opposite angle, they will be equal, right? And
Yes, sir.
BM is equals to MN, obviously, they are equal. So which angle? Which one more angle?
So
These two are vertical opposite angle. And can we say ABM equals to MCN? ABM equals to MCN. Are they equal? Alternate angles.
yes,
ABM
sir. Yes, sir, they are.
and MCN, they are equal, right? Okay. If this happens, then the area of these two triangles, ABM, will be equal to triangle AMC. Sorry, MNC, right? First of all, we saw the two triangles congruent by showing this A as a test verified. After doing so, we will write these two triangles congruent, and after writing the two triangles congruent, we can write here triangle ABM, area of triangle ABM equals to area of triangle MNC. Okay, after this, after this, what we can write here is, can we write AM equals to MN? Can we write AM equals to MN? AM equals to MN. Can we write?
So
When the triangles are congruent, then what happens to the corresponding sides?
they are
Are
equal.
the corresponding sides equal?
Yes, sir.
Yes.
Oh,
So
yes, yes, sir.
being corresponding sides of the congruent triangles, they will be equal. Now, why I'm saying this one is because if this happens, then in the triangle, ADM, ADN, ADN, can we say that it is the area of triangle ADM equals to area of triangle DMN? DMN, can we say? When AM equals to MN, in triangle ADN, can we say the triangle area of triangle ADM is equal to the area of triangle DMN? Can we say? Oh, hello, people. Can you
Yes,
say?
sir.
Look at here. In triangle ADN, if M is the midpoint of AN, DM becomes median, right? DM becomes median, and that helps us to bisect the triangle into two equal parts.
Yes, sir. We
So
can.
we can, yes. Now, what next? We have to show the relation of ADM or AMD to the area of trapezium. Now let's write it AMD because that's the order of the vertices in to prove. So let's write this one as AMD, not ADM. AMD. AMD equals to AMD equals to DMN, right?
So what we have to prove? Can you show me that? So can you show me the question? So proved.
Proved.
Yes, sir.
Okay, tell me how to write it. AMD equals to DMN. Then
Yes, sir. And triangle ABM. Hello.
okay, triangle ABM equals to triangle. Yes, I use AMB equals to ABM equals to triangle DMN. We have already proved here.
Yes, sir.
MNC. I mean,
Yes, sir.
okay, one second. AMD equals to DMN, right? DMN. And DMN is DMN is DMN is DMN DMN sum of triangle MDC plus triangle MCN. Is it?
Yes, sir.
Triangle MDC plus which triangle is equals to MCN? Oh, let's write this one in order. Wait. Let's write this one in order. MNC. Which triangle is equal to MNC?
Triangle ABM.
ABM. Triangle ABM. Triangle ABM. Now, what is the sum of these two triangles connected to the area of trapezium?
So it's triangle ABM and MNC.
Yes. Triangle DMC. Triangle DMC plus triangle ABM. How is this related to triangle? How is this related to trapezium ABCD? How? Is there any connection? Can you see any connection? No?
No, sir.
Let's figure out here. ABCD ni, and by whole part exam, ABCD is, can we write ABM plus MDC plus AMD. Can we write? Can we write?
Yes, sir. We can.
ABCD equals to ABM. Wait. ABM plus
Yes, sir. We can
MDC
write.
plus AMD. Now, what we want to show here is we want to show here the relation of MDC and ABM to this trapezium ABCD. Now, how can you replace this AMD? Can't we say this is half of trapezium ABCD? Can you figure out? Can we prove that this is half of ABCD? These two sums, the sum of these two triangles.
Yes, sir.
Because see, we have proved that ADM or AMD is equal to DMN, right? We have already proved that AMD equals to, wait, we have already proved that A, we have already proved that AMD, AMD and DMN are equal, right?
Yes, sir.
Did we prove? So let's write here, let's give here the numbers 1, 2, 3, 4. So replacing one on another, we can prove this one. Just think for 1 minute. Did you think? A B M plus MDC plus AMD was proved equal to triangle DMN. ABM plus MDC plus DMN. DMN can be written as the sum of MDC. MDC plus MNC.
MNC, yes, sir.
MNC, right? MNC. So MDC is twice MDC plus ABM and MNC are equal, right? ABM and MNC were equal. So in place of MNC, we can write ABM plus this one also ABM. ABM. So this 2 will give you 2. Taking 2 common, you can get here MDC plus ABM. ABM. So taking this 2 to that side will be half, right? So MDC, triangle MDC plus triangle ABM is half of trapezium ABCD. So in place of this one, you can replace this value and write it as half of trapezium ABCD. Can you connect now?
Yes, sir.
Okay, think for a while because this is a little bit confusing. Miss Sovana and Dungana, Rupesh Dungana, are you there?
Yes, sir.
What are you doing there? I think you are sleeping there.
No, sir, I'm listening to you.
Listening will not help us, obviously, if you don't try, right?
Yes, sir.
Now, since we have learned that you have friends in LA, we'll figure out what type of lady you are, dear.
Okay.
Right? Ayus,
Yes, sir.
We'll figure out what type of girl is Sobana.
So out.
She has friends in LA. Your
So, but I don't know
mates.
her.
Your mates.
So, but I don't know her.
Okay. So think for a while about this question. Can you replace now? Can you prove this one now yourself with the proper reasons and statements? Sobana, Miss Sobana.
Yes, sir.
Okay. So we have class after this also. So I'm leaving now. We'll meet after 4 minutes.
Okay, sir.